Welcome back to a new video lecture, and in this lecture we discuss a new topic and it is related with the circular beam. So here you can note down that this circular beam is loaded with uniformly loads and it is supported symmetrically. So if you observe here you can observe that the circular beam is given with the different supports are also provided. And what's the specialty of providing these supports? If you observe that these supports are symmetrically spaced, okay, the distance throughout it is going to be equal, such that if you are taking a small section here, that is AB here, then you can easily note down in this way, that is 2 theta equal to 360 by n. What do you mean by this n and this 2 theta actually 360? Actually the total degree is going to be 360, and if you are only taking a small portion, that is AB, let us take AB, then it is going to be 360 by n, and this n represents this number of supports actually. Okay, so that's the case. And if you observe this AB portion very carefully, this is AB portion. Okay, so in this case you can observe that what all things is we considered in the case of the previous lecture, that same thing here also we are going to repeat here, that is to find out the reactions, then shear force, then bending moment, then twisting moment. Okay, so if you consider here you can visualize 2 points as AB, and the total angle it is going to be make us 2 theta angle, since we are going to take from this small portion from here. Okay, and then if you observe here, this uniformly distributed loads are acting here, so this total load it is going to be act at this point. Let us take this point be E. Okay, so let us take this point be E, and here you can note down that M0 moment is also acting in this direction. From this support, this M0 moment is acting in this direction. And if you split the components or the vector directions, you can take this M0 cos theta in this direction and M0 sin theta in this direction. Okay, then if you are only considering this small portion, okay, if you are just considering this small portion only, then this load is going to be act, let us take this point be F for F. Okay, so that's the case. So if you observe this ED, it is going to be, if you are observe this distance, it is going to be OE minus OD, isn't it? OE minus OD. Then to find out this ED distance, this OE it is going to be, we already discussed this value, that is R sin theta by theta. Then how you got this OD distance R cos theta? For finding out that, you have to consider this triangle, isn't it? Okay, if you apply, you will get this value. Then the reactions at each supports will be, to symmetry it will be equally, isn't it? R and RB is going to be same. So what about the total load acting? It is going to be WR multiplied by 2 theta. Okay, this is the angle between this AB portion. So the total load over this portion AB, it is going to be WR 2 theta. And the reactions will be both sides. So you can divide by 2. So you will get, that is WR theta at both A and B. Then using these reactions, you can calculate the shear force. And at the support A, if you observe this support A, the reaction value is going to be WR theta. So obviously the shear force at the support is also going to be WR theta. So that is mentioned here, WR theta. And If you resolve all the terms, we already discussed this m0 sine theta and m0 cos theta according. Balancing the moments about the chord AB. Okay, so if you observe here, this is your AB. And if you observe here, from this support A, there is m0 sine theta. And from the support B, there is also m0 sine theta. Both are acting in the same directions. And here at the point E, the total load is also acting. So actually, if you are considering this AB portion as your axis, or about this AB portion, there will be only this m0 sine theta and this m0 sine theta. And also, what about this loads is acting over this point E, and then multiply with this distance ED. That's why we have determined this value, ED equal to r sine theta by theta minus r cos theta. So if you substitute those values, that is 2m0 sine theta equals w multiplied by ED, you will get this total w, that is going to be 2w r theta, then multiplied by ED, already we determined, and finally you will get this m0 value at the supports going to be wr square multiplied by 1 minus theta cot theta. Okay, after substituting those values, this theta will be cancelled, and after this sine theta to be in this side, you will get this value. Okay, so that is regarding the bending moment at the supports. Then let us take some points, that is shear force and bending moment at any point. For finding out that, let us consider a point there, and if you observe the shear forces, the total force, that is going to be wr theta at the reactions minus load over the arc. Okay, that is if you observe here, and if you're taking an angle phi here, then that is going to be wr phi. Okay, wr phi here. Up to this much it is going to be phi. This much distance, sorry. Okay, this much distance it is going to be phi. So you will get wr phi. Okay, the value it is going to be wr phi, and here this w r theta value also here. So wr theta minus wr phi will get, and if phi it is going to be 0, it is obviously going to be wr theta. And at the mid span, if you consider mid span, and let us take an example, 6 supports are provided, then what about this theta value, that is 2 theta, it is going to be 360 by 6, it is going to be 60. Then theta it is going to be 30 degree. Let us take an example only. So finally, if you convert those values, that is theta and phi to be radians, you will get, and finally you will get 0 value. So shear force at the midspan, it is going to be 0. Okay, this is the general equation, and with the help of this general equation we can come to this conclusion, that is when phi equal to 0, it is going to be wr theta, and when it is at the midspan, it is going to be 0. Okay, and if you observe bending moment at any point about PO, okay, about PO means, let us take this point to be P. Okay, so moments are taken for the section at about radial axis PO, that is this axis. If you are taking this, then here you have to consider, we are going to split this moment with respect to this phi angle. Okay, so if you observe, this will be m0 cos phi, and in this direction this m0 sin phi to be marked. Okay, in this direction this m0 sin phi to be marked, and here this E point, okay, this E point represents the total load acting over this portion, AP portion. Okay, this AP portion, what all loads are acting, that is represented here. Okay, so for finding out this moment at a point P, what all loads is going to be active? So here if you observe, F0 multiplied by AH, F0 multiplied by AH is this perpendicular distance. Then minus W5 multiplied by EG, EG represents this distance. Then one more thing that is going to be M0 cos phi. Okay, that is actually moment. So there is no distance is required. And M0 sin phi has no influence. Okay, that is also to be noted. Then you can directly substitute those values. Okay, you already determined those values, and if you substitute, and here also this AH and EG you can calculate from this right angle properties. That is, AH is going to be R sin phi. That is, you can consider that right angle triangle here. Okay, this right angle triangle, you will get this R sin phi. And then EG, it is going to be, if you observe EG, this one, so and it is going to be phi by 2. So it is going to be OE sin phi by 2, and this point E represents the total load is going to be acting. So R sin phi by 2 by phi by 2. Then this, if you substitute this EG, it is going to be 2R sin square phi by 2 by phi. Okay. Then after that you can substitute all those values. Okay, after substituting you will get this M phi equals WR square multiplied by those values. And for this integration easiness, we are substituting this one positive here and one negative. And if you combine those terms, you can write down cos phi equals 1 minus sin square phi by 2. And such that those terms will be cancelled out. Okay, and finally you will get this equation, that is theta sin phi will be here, and theta cot theta cos phi, and this remaining minus 1 here. So this will be your equation, final equation, bending moment equation. Then coming to the twisting moment, if you observe, this will be your general equation. Okay, that is M0 sin phi plus W phi PG minus F0 PH. So again, if you observe here, in this case, this M0 sin phi will have the role, and this M0 cos phi, there is no role for the twisting moment. So this M0 sin phi will be acting in the same direction, that is in this case. Okay, and this distance to be taken, this lever arm distance, and PH also you have to take in this way. And if you observe this PH, it is going to be R minus OH, isn't it? This radius minus this OH gives this PH. And OH, it is going to be R cos phi from the right angle triangle, R cos phi. Then PH, it is going to be R minus R cos phi. Then what about PG? It is going to be R minus OG. This PG, it is going to be R minus OG. And you can calculate this OG as this OE as R sin phi by 2. And this OG, it is going to be OE cos phi by 2. Okay, this right angle triangle if you consider. Okay, don't get confused. Okay. Then after that, this OG, if you substitute those values, you will finally get R sin phi by phi. And after that, you can substitute those values here. And finally, this PG value is going to be R minus R sin phi by phi. Okay. So after substituting those values, you can clearly observe that this will be your final equation. Okay. After substituting this WR square to be taken outside, and their substitutions here, this sin phi and this sin phi cancel out, remaining this and this theta cos phi minus theta cot theta sin phi. Okay, minus of theta minus theta, fine. Okay, then for when phi equal to 0, you can observe that if you substitute 0 here, it is going to be 0, here it is theta, then this theta minus theta 0. And if you take the same case at the midspan, if you observe there also, it is going to be 0. Okay, that is for 6 supports. If you observe theta, it is going to be. 30 degree, and finally it is going to be 0. Find out the maximum torsional value, you can take the derivative with respect to 0. So you will get this equation, that is when this phi m value, if you substitute those values as the maximum torsion value you will get. And one more thing you can note down, that when you are getting the maximum value for the torsional moment, the bending moment value it is going to be 0. When you are getting the maximum torsional value, the bending moment value it is going to be 0. And you can note down that the support moment m theta, then mid span moment is going to mc, and this twisting moment, maximum twisting moment mt max. And you can represent those equations in a general statement, that is c1 multiplied by wr square is a common term multiplied by 2 theta, and here this c2 another constant, and here another c3. Since for the calculations, if you observe here, this mt phi, it is going to be, this twisting moment is going to be wr square multiplied by this long equations, and these all terms are comprised to one constant terms. So if you observe here this bending moment value, okay, that's also very big equations. So all those terms are going to be into a very simple equation, that is c1 wr square 2 theta likewise. And we can here observe various values for those constant values, and let us see these supports. According to the supports, this angle also will vary, that is 360 degree divided by n, number of supports, you will get this 2 theta value, isn't it? So let us take these 6 supports, you will get is going to be 60 degree, so that is represented here. And if 4 supports, it is going to be 360 by 4, you will get 90. So corresponding c1, c2 and c3, that constant values, and also the at which angle the torsional value it is going to be maximum, that is also mentioned here. The torsional maximum value also going to be mentioned here. So these are the things to be remembered while doing the circular beam analysis. Okay, so I hope the section is clear, and with this we wind up today's section.